This is the solution video for section 4.4, problem number 7. In 7 and 8, find the local extreme values using the second derivative test. All right, so second derivative test says if f prime of c equals 0 and f prime of c is greater than 0 or less than 0 or equals to 0. So first thing we need to know is when does f prime equal 0? All right, so f prime of x is 12x cubed minus 12x squared, right? So that's f prime. So now we want to set that equal to 0. All right, so if I set that equal to 0, I get 12x cubed minus 12x squared equals 0. So I'm going to factor out a 12x squared, which leaves me with x to the first minus 1. All right, and so now 12x squared, right? So I'm going to set 12x squared equals 0 and x minus 1 equals 0. All right, so now if I divide by 12 and square root, I get x equals 0. Here I add 1, I get x equals 0. All right, not x equals 0, sorry, x equals 1. All right, so now the second part of the second derivative test says if f double prime is positive, you must have a local minimum, right? Because the first derivative is 0 and the curve is concave up, right? Or if f double prime is negative, you must have a local max. Now, if f double prime equals 0, then the test is inconclusive. So what we want to do is we want to find f double prime and then evaluate f double prime at 0 and 1. All right, so f double prime is, derivative of 12x cubed would be 36x squared minus derivative of 12x squared would be 24x. All right, and so we want to evaluate f double prime of 0. So what is f double prime of 0? 36 times 0 squared minus 24 times 0. All right, and so that is 0. So that would mean, okay, that second derivative test is inconclusive at x equals 0. All right, but what about f double prime of 1? All right, so 36 times 1 squared minus 24 times 1. All right, so 36 minus 24 is 12, which is greater than 0, meaning we must have a local minimum. So local minimum at x equals 1. All right, but what is f of 1? Because remember, the directions said find the local extreme values, which means we're looking for the y value. So then I need to plug 1 into the original function. So 3 times 1 to the 4th minus 4 times 1 cubed plus 6. So 3 minus 4 is negative 1 plus 6 is 5. So the local minimum is 5 at x equals 1. All right, but what about 0? Well, what is 0? Well, we would have to go back and revert to the first derivative test. So I'm going to put 0 and 1 on my number line, and I'm going to put 12x squared, and I'm going to put x minus 1. All right, so now I have two rows, a 0 above 0 and a 0 above 1. All right, and so now to the left of 0, well, if I take any negative number and I square it, I'm going to get a positive, and any positive number squared, I'm going to get a positive as well. All right, what about over here? Number to the left of 1 like 0, 0 minus 1 is negative. Number to the right like 2 is positive. So the first derivative is negative here, positive here. So this verifies that there is in fact a local minimum at 1, and there is neither a local minimum or maximum at 0.